Today we will discuss how to find integral 0 to pi by 2 sine raised to nx dx. So how to find integral 0 to pi by 2 sine raised to nx dx? Let in equal to integral 0 to pi by 2 sine raised to nx dx. Now we will split this sine raised to nx dx as integral 0 to pi by 2 sine raised to n minus 1 x sine x dx. So this is in equal to this. Now take this as equation number 1. Now we will find integral of this separately with integral sine raised to n minus 1 x sin x dx. This is product of two functions. So we will apply integration by parts rule. That is, we will not take we will take separately integral sine raised to n minus 1x sin x dx. Here the rule is first function integral of second minus integral of derivative of first multiplied by integral of second. That is the rule. That rule we will apply here. That is the rule. Integration by parts. First function what is sine raised to n minus 1 x, and the integral of second, that is equal to minus cos x. Then minus integral of closed bracket, the derivative first is n minus 1 sine raised to n minus 2 x. It is a function of function. So sin x derivative is cos x. We have to multiply by sin x derivative cos x. Then integral of second is minus cos x and integral. And this is equivalent to sine raised to, there is no change, sine raised to n minus 1 x cos x. Negative will be here, minus here n minus 1, integral n minus 1 outside, integral of sine raised to n minus 2 x cos square x dx. This minus will make this negative positive, and that is equal to integral sine raised to n minus 1 x cos x plus n minus 1 integral sine raised to n minus 2 x cos square we will convert as 1 minus sine square x dx. So this is equivalent to there is no change in the sine raised to n minus 1 x cos x plus we will multiply n minus 1 multiplied by this multiplied by 1. So we will get n minus 1 will get n minus 1, we will get n minus 1 multiplied by sin raised to n minus 2 x, sin raised to n minus 1, sin raised to n minus 2. Here we will get integral, we will get this result, n minus 1 integral sin raised to n minus 2x dx minus n minus 1. This n minus 1 multiplied by this multiplied by sin square. So it will become sin raised to integral sin raised to nx sin raised to nx dx, sin raised to nx dx. So this is equivalent to minus sin raised to n minus 1 x cos x plus n minus 1. What is this left side? Left side is actually, it is equivalent to this is integral sin raised to n minus 1 sin x. So we will find in. When it will become in, integral 0, definite integral 0 to pi by 2. So we will put here values 0 to pi by 2, 0 to pi by 2, 0 to pi by 2, integral 0 to pi by 2, sin raised to n minus 2 x dx minus n minus 1 integral 0 to pi by 2 sin raised to nx dx. Now we will go to next page, that is equal to in equal to we will put the values here, putting pi by 2 upper value sin pi by 2, sin 0 0, cos 0 1, cos pi by 0, so upper value 0. So this is equivalent to 0 minus 0, then integral, then minus, here we will see that page, here n minus 1. So we will see plus n minus 1 integral 0 to pi by 2 integral 0 to sin raised to n minus 2 x dx minus n minus 1 integral 0 to pi by 2 sin raised to nx dx. So this is equal to n minus 1 by symbol. We can write this expression. Of in minus 2, and left side is in, then n minus 1 multiplied by in. On simplification, we will take in this to the left side, plus this will become plus n minus 1 in equal to n minus 1 in minus 2. So this will become in get cancelled, so n equal to n minus 1 in minus 2. So this is one stage, in minus 2. We will simplify in minus 2. We will find in minus 2 using this formula. If n is n minus 2, what will be? So we will find like that. So what is in? Finally, in equal to n minus 1 by n multiplied by in minus 2. In. From this in formula, we will find in minus 2. How to get in? In is n minus 1 less divided by n and 2 less. So what will be like this? We will find in minus 2. In minus 2, repeating this formula here, n is n minus 2. So n is n minus 2 means 1 less, that is here 1 less. So we will get n minus 3 divided by n minus 2. N minus 2. So n minus 2 minus in minus 4. Like this we will get in minus 4. In minus 4 means 1, n means n minus 1. So 1 less, that is n minus 5. Here 2, n means n. So n minus 4 means n minus 4. N means n minus 2. So here n minus 4 minus 2, in minus 6. So we have got like this. We will derive other last terms. Last terms we will see in here where n is greater than or equal to. So n can be 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. So here all this actually the 2 is even, 4 is even, 6 is even, 8 is even, and 3 is odd, 5 is odd, 7 is odd, 9 is odd. So it is n can be odd numbers, n can be even numbers. We will see how to derive the final formula for this sine raised to 0 to pi by sine raised to nx, the final formula. So we will go to next stage. Here, going like this, we will come to the formula if n is odd, for example 3. So what will be I3 equal to 2 by 3, 1. So if n is odd, it will be, if n is odd, then the last term will be I3. Finishing term of this I3, that will be equal to 3 means 3 minus 1. 3 minus 1. So 3 means 3 minus 1, that is 2 by 3. 2 by 3 into, when it is n minus 2. So it is 3 means 3 minus 2. So I 1. If n is odd, otherwise that means, so n can be odd or even. If here if n is odd, this last term will be I3, 2 by 3, I1. Or I2, 1 by 2, I0. If n is even. If n is even, last term will be I2 equal to 1 by 2, I0. Now we will combine this expression. We will replace in minus 2 by in minus 2 by this expression, in minus 4 by this right side expression, like that. We will combine this. We will combine this result. We will combine. So combining, we will get integral 0 to pi by 2 sine raised to nx dx, that is equal to in. So in equal to n minus 1 n minus 1 in equal to n minus 1 divided by n in minus 2, that is equal to n minus 1 by n. We will replace in minus 2, that is n minus 3 by n minus 2 in minus 4. Now again we will replace in minus 4, that is equal to n minus 1 by n. We will repeat the step like this: n minus 3 divided by n minus 2, etc., multiplied by last term will be 2 by 3 into I1 if n is odd, and equal to n minus 1 by n minus 3 by n minus 2 multiplied by last term will be 1 by 2 I0 if n is even. This is the formula. So this is integral 0 to pi by 2 sine raised to nx dx. Now we will find I1. What is I1? I1 equal to integral 0 to pi by 2 sine raised to 1x dx, that is equal to integral 0 to pi by 2 sine x dx. Integral of sine x equal to minus cos x between 0 to pi by 2. So cos pi by 2 0, cos 0 1. So 0 minus 1, that is equal to 1. So we got I1 equal to 1. Similarly I0. What is I0? Integral 0 to pi by 2 cos integral 0 to pi by 2. What is I0? What is I0? What is I0? I0 is equal to integral 0 to pi by 2 sine raised to 0 x dx. You know, any number raised to 0 is 1. So integral 0 to pi by 2 1 x, that is equal to integral of 1 is x 0 to pi by 2. So the value is pi by 2. So I0 is equal to pi by 2. Now we will go to next page. So what is integral final value? Integral 0 to pi by 2 sine raised to nx dx equal to n minus 1 by n, n minus 1 by n, n minus 1 by n, then n minus 3 by n minus 2 to n minus 3, again n minus 5 divided by n minus 4, etc. The last term will be 2 by 3 into 1, 2 by 3 into 1 if n is odd, equal to n minus 1 by n, n minus 3 by n minus 2, n minus 5 by n minus 4, etc. Last term will be 1 by 2 pi by 2 if n is even. Now we will see some examples. We have understood this formula, so we will see some examples. First one is 1. Integral 0 to pi by 2 sin square x dx, and that is equal to 2. So first term will be 2 minus 1, that is 1 by 2. If it is coming with 1 by 2, then it is last term will be pi by 2. So the answer is pi by 4. Second example, integral 0 to pi by 2 sin cube x dx. So first term is 3 minus 1 by, that is 2 by 3. If it is ending with 2 by 3, then last term will be 1, equal to 2 by 3. 3. Integral 0 to pi by 2 sin raised to 4x dx, that will be equivalent to 3 by 4, then 2 less 3 minus 1, that is 2 less, that means 1 by 2 into pi by 2, last time will be pi by 2, that is 3 pi by 16. Then fourth one, integral 0 to pi by 2 sin raised to 5x dx equal to 5 means first term will be n minus 1 by n. That means 4 by 5 multiply 2 less 2 by 3 multiplied by 1, that is 8 by 50. The last example is integral 0 to pi by 2 sin raised to 6x dx, that is equivalent to 6 is even, so it will be 1 less 5 by 6 into 3 by 4 into 1 by 2. If 1 by 2 comes, then last time will be pi by 2. 5 pi divided by 32. So these are the examples, and this is the formula for finding integral 0 to pi by 2 sin raised to nx dx. Here n means n minus 1. First term is very important, n minus 1 divided by 8. Here also n minus 1 divided by 8. Last term will be 2 by 3 into 1 if n is odd. Last term will be 1 by 2 into pi by 2 if n is even. So thanks.